Let's see this question. This question is asked in GATE 2013 in the subject digital. In the circuit shown below, Q1 has negligible collector to emitter saturation voltage and diode drops negligible voltage across it when it is in forward bias. If VCC is plus 5 volts, X and Y are digital signals with 0 volts as logic 0 and Vs as logic 1. The Boolean expression for Z is given. This is the circuit, this is Q1 transistor and this transistor is of type NPN. This is the diode. Given negligible collector to emitter saturation voltage. Collector to emitter saturation voltage VC is sat is negligible, so we can write 0 volts. And diode drops negligible voltage across it when it is in forward bias. When it is in forward bias, diode is in on state, so VD on is equal to 0. Now for this transistor Q1, if we apply only positive voltage, then it is said to be in on condition. For transistor Q1, if you apply positive voltage, then it is in on state. Now for this diode, here it is P side, here it is N side. If P side is more positive, then diode will be in forward bias and it is in on state. For the diode, if P side is more positive, then only it is in forward bias and it is in on state. When it is in forward bias, it acts as short circuit. Okay. When diode is in reverse bias, it will be in off state. It will be acting as open circuit. Now we will take the values of X and Y. We will calculate the values of Z. Okay. Now we will formulate a table with the values of X, Y, okay, and transistor Q1 and diode D and Z. Now if X is 0, Y is 0. If X is 0, then transistor Q will be in off state. Okay, Q is in off state. Now if Y is 0, this diode will be in forward bias. If Y is 0, diode will be in forward bias because more positive voltage is across P side. Okay, this will be in on state. Forward bias, on state. And now this is off state. Here it is forward bias. So it will act as short circuit. So Z will take the value of Y, that is 0. Now 0, 1. Same, if X is 0, Q1 is in off state. Okay. Now here, if Y is equal to 1, this side is more positive compared to this side. So this will be in reverse bias. So off state and reverse bias. Okay. Now this will be off state reverse bias, so it acts as open circuit, and transistor is also it is off state. So it will take the value of VCC. Since no current flows, no voltage will be dropped across R. So directly, what is the value of VCC? That will be taken by the Z. So VCC is plus 1. Now it is 1, 0. If X is 1, transistor is in on state. If Y is 0, diode will be forward bias and act as short circuit, so on state. So now if this is on state, so Z will take the value of ground, okay, so which is 0. With respect to diode also you can take, this is 0, so this will be forward bias, act as short circuit, so Z will take the value of Y, which is 0. So in any manner, if you see with respect to transistor it is 0, with respect to diode it is 0. Now 1, 1. If X is 1, transistor is in on state. If Y is 1, this will be short circuit, off state. Sorry, if Y is 1, you see Y is 1, this side is more positive compared to this. So this will be, if Y equal to 1, this will be in reverse bias. Reverse bias in the sense it acts as open circuit. So Z will take the value of ground, that is 0. From the given table, by seeing X value and Z value and Y value, okay, we need to derive the equation for Z. For X0, Y0, Z is 0. Okay, it might be X into Y, because if 1 is 0, the other will also 0. But you see here, if for 0, Y is 1, Z will be 1. So we can put bar. Now test Z equal to X bar Y. If X is 0, this will be 1. This is Y is 0, this will be 0. So 0. First condition satisfied. Next, If x is 0 means 1 into 1 is equal to 1. So this also satisfied. For this, this is 0 and y is 1, that will 0. So satisfied. For this thing, x bar is 0 and this is 1, 0. Satisfied. So answer will be z is equal to x bar y. So z is x bar y.